Let's do some practice using these forms. We're going to start by looking at an example where we have a grid that's superimposed over the quadratic path of a basketball. So most things that we throw in motion, as long as we ignore air resistance, behave quadratically, all right? Because we have linear horizontal motion, and then gravity is essentially quadratic for that position part. Does he make the basket? I don't know. Well, one way that you can do this is you can kind of say that, well, parabolas are symmetric. So assuming that this is the vertex, which is an important assumption, but assuming this is the vertex, and maybe don't write on this with blue, I don't know, then what is the ball doing? Well, then it's going to be symmetric, and it's going to look, oh gosh, this is hard. It's going to look kind of like this path. And then it keeps on going here a little bit, I think. And, oh no, disaster. Well, it looks like it's going to rebound out, right? It looks like it's going to hit the edge and bounce out. I'm going to say no. It's looking like a no. But let's find the equation first, okay? Let's say that this is the origin down here. Let's say that's 0, 0. Then what's the vertex? Well, the vertex is going to be 1, 2, 3, 4 units to the right. 1, 2, 3, 4, 5, 6, 7 units up. So it looks like our vertex is 4, 7. Well, then we use vertex form. Vertex form says we have f of x equals a, I don't know what a is, times x minus h, just the vertex, right? This is our h, this is our k, squared plus k. We need to find a. Remember when we were finding equations of lines? Remember when we were finding equations of lines and we found our slope and we needed to find b? What did we do? We used a point. We plugged in a point. That's going to be very similar here. But the difference is that we're going to use not the same point. If we use the vertex, you're going to get 0 equals 0, which is a little silly. But we're going to use a point that's not the vertex to find a. So what's another point that this ball is at? Point right here looks like a pretty easy point to look at. Pretty easy point to use. That's 8, 0. So we're going to use the point 8, 0. Our output is 0 when our input is 8. Replace the output with 0 and the input with 8 and solve for a. Let's simplify this. 0 is equal to a times 4 squared plus 7. 4 squared is 16, so we get 16 times a plus 7. We subtract 7 from both sides. Divide both sides by 16. It's negative 7 over 16, which doesn't look great. Should we have a negative a value? Should a be positive? What do we know about a? A is positive, graph will open up. A is negative, graph will open down. Oh, we should have a negative a value, right? It should be opening down. So we know our function now, right? F of x is a, which is negative 7 over 16, times x minus h, which is 4, squared, plus k, which is 7. This is the first half of the problem. And now let's see if our basket really does get made. Let's use some math. Where do you think the ball has to go to be in the basket? I don't know. Let's find out what the function value is at 1/2. When x is 1/2, what's the y? If the y value is here, yeah, you might make the basket. If the y value is way up here, No, it's moving to the left. That's not going to, well, it's going over the backboard. Right? And if the y value is down here, yeah, you really messed up. Let's find the y value when the input is a half. All right. Let's see where it's going there. Let's find f of 1/2, and we'll use a calculator. Here, I don't know if I've mentioned this before, but here's a fun way of using Desmos to make things easier. You can type in your function like this. F of x equals -7/16, x minus 4 squared plus 7. Okay. You can also just type in what is the function evaluated at 1/2. And that tells us the answer is about 1.64. So what does that look like on the graph? It says with the input's a half, the output is a little. Oh. So it looks like our black trajectory is right. So this is in the basket, but I don't think that's going to work. I don't think that's going to work at all. It'll fall below the basket. I don't think it's going through the top. So I'm going to say no. Even though it looks like the function value is in the basket. That's not how baskets work. I'm not very good at basketball, but I'm pretty sure you need to go through the part at the top. Just say no. It goes under the basket. We'll give him a sad face. So we can model projectile motion with quadratics. The path of a basketball. Path of rockets. Missiles. If you're interested in combat and stuff like that, well, how these targeting programs work is they're very complicated projectile motion problems, and they do take into account air resistance. Okay, it can look at the motion. Basically, motion is a big application of quadratics in general. Anyway, let's not think about that anymore. Example 3, right? G of x is equal to that. Okay, so let's translate something from vertex form into standard form. So to do that, we have to remember what standard form is, right? Standard form is the form ax squared plus bx plus c. We already know what a is here. A is a half. How do I know that? Because I said in these forms, the a is the same. If you have a half in front of this x squared, you're going to have a half in front of the parentheses. So we know a is a half. But instead of doing anything really fancy and solving for a, b, and c in some weird way, what we're going to do is we're just going to simplify. If we simplify, we're going to get this. Don't believe me? I'll show you. So we know that g of x is 1/2 times x plus 2 squared. Careful, that's not x squared plus 4. X plus 2 squared, if something is squared, that means it's being multiplied by itself. What is a binomial? X plus 2 is a binomial. What is a binomial times a binomial? We have to FOIL. Okay. First, outer, inner, last. Every pair needs to get multiplied by each other. So x times x is x squared. X times 2 is 2x. X times 2 is 2x. And 2 times 2 is 4. So we're following order of operations. We're doing the squared part first, the exponent first. And then we just keep simplifying. The inside becomes x squared plus 4x when we combine like terms. We have 2x, we have another 2x, add them together, that's 4x. Nothing else is a like term. Now we distribute. Get 1/2 x squared. 1/2 of 4x is 2x. 1/2 of 4 is 2. And now we have these like terms that we need to combine. We get 1/2 x squared plus 2x minus 1 is our function. And it is indeed fully simplified. And when we fully simplified it, that is standard form. Ax squared plus bx plus c. C is -1 in this case. All right, and let's say you're a little nervous. Say, I don't know if this is the same function or not. One thing that you can do, you can graph both functions, either by hand or with a computer. So let's say g of x is 1/2 x plus 2 squared minus 3. Actually, you don't even have to graph both forms. Watch this. Let's graph the vertex form, or let's graph standard form. 1/2 x squared plus 2x minus 1. What's the vertex? It's -2, -3. That should be the vertex, right? The vertex form says x minus h. So h is +2. Plus k, so k is -3. Oh, we graphed it in standard form, we can see, and then the a value is always going to be the same. We know the a value of 1/2, a value of 1/2 matches. Don't even need to grab both of them. You can just graph the standard form and see that it matches what we know from vertex form. All right, let's do one more pair of examples. And we can do some shortcuts. So if we have a quadratic in standard form, the vertex h is when h is equal to -b over 2a. So remember, if something's in standard form, right, that's going to be f of x is ax squared plus bx plus c. If it's in vertex form, we don't need to find the vertex. If it's in vertex form already, that gives us the vertex. But if we're in standard form, if we're right here, the h coordinate for the vertex is -b over 2a. And then the k value is just, what is this? This is the function evaluated at the h. It's the output when the input's at the vertex. And where this formula comes from is we complete the square on this. I'm not worried about completing the square in this class, so we're not going to derive it ourselves. If you wanted to complete the square on this, you could put it into vertex form, and you'd get that formula. So let's use this. Find the vertex of this quadratic, and then write it in vertex form. So we know the vertex is h comma k. Also, we know h is -b over 2a. And we know k is a function evaluated at h. That's what we got all from up here. Now we just have to use this information. Well, what's -b? Well, a is 2, b is -6, c is 7. Watch out for those negatives. That negative is attached to the b value. So this whole thing is our b value, -6. So what's the opposite of b? We have a -6. You could just turn that into a +6 if you wanted to. Divided by 2 times a, we said a was 2. Negative times a negative is a positive. 6 over 4, 3 over 2. That's the h coordinate. Now, if k is just a function value at h, that's going to be the function value at 3/2. And you can use a calculator to find this. I'm going to go over and use a calculator. I'm going to say f of x is 2x squared minus 6x plus 7. And say, okay, what is f? What is the function value at 3/2? I could also do 2 times 3/2 squared minus 6 times 3/2 plus 7. 2 ways of getting that function output. Good practice to use your calculator, though. It's 2.5, which is 5/2. I like to be consistent. Let's have either both things as decimals or both things as fractions. Remember, on Desmos, you can click this fraction bar to get the fraction form. So that's our k. We have our h and our k. We know vertex form is a times x minus h squared plus k. So our function is a. We already said a is 2. The same A in both forms. A is 2 times x minus h. We said h was 3/2. Squared plus k. We said that's 5/2. A couple ways we could check our answer. We could simplify this, see if it's equal to our vertex form. Or we could just see if, graph the other one. Is this vertex at 3/2, 5/2? It is. 3 divided by 2 is 1.5. 5 divided by 2 is 2.5. They have the same A value. It's opening up. Positive A value as we expected. Didn't realize this video was going to be so long. But do some practice. Pause this video. Try to do this. Write it in standard form and vertex form. So standard form is going to be ax squared. In this case, a is 1. Right? A is the coefficient of x squared. B is the coefficient of x. And c is the constant. So ax squared plus bx plus c. That's standard form. To put it in vertex form, we're going to need to find the vertex. H is negative b over 2a. The opposite of b, positive 6, divided by 2 times a, which is 1. Our h value is 3. K value is just the function evaluated at that input. Right? The vertex is an input and an output. We found the input. To find the output for that vertex, plug it into the function. Oh, not f. Our function's named g here. That's going to be 13 plus x squared minus 6 times x. It's 13 plus 9 minus 18. I believe that's 4. 22 minus 18 is 4. So our vertex is an input of 3, an output of 4. So in vertex form, our a value is going to be the same. It's just 1. You don't have to write the multiplication by 1. X minus h, which is 3, plus k, which is 4. You could graph both of these functions and see that they are the same function. Let me know if you have any questions. Have a great rest of your day. Enjoy working on this problem, and I will see you next time for some applications. Example 0 is coming back again. Let's go. Bye-bye. Thanks for sticking with this 18-minute long video.